Hello, my name is Steve Ardrey. I'm the field supervisor for the Instrumentation and Controls Department at the Southeast Wastewater Treatment Plant in San Francisco. This display is an overview of our wastewater treatment process here at our plant in San Francisco. The treatment of wastewater is critical for public health as well as the health of the environment. You may not realize it, but I use a lot of chemistry and math in my work here at the Southeast Treatment Plant.
Hello, my name is Charles Johnson, and I'm an instrumentation and controls technician here at the Southeast Wastewater Treatment Plant in San Francisco. I'm going to talk with you about how we monitor and control oxygen in our treatment process.
Hello, I'm Lolita Wilkins. I'm a wastewater treatment plant operator at the Southeast Treatment Plant in San Francisco. The microorganisms we use in the treatment process require oxygen just as humans do to live. Sewage is low on oxygen, so part of our process is to increase the amount of oxygen in the wastewater that's being processed in the aeration tanks. The display that is shown on the screen is the one that we use to both monitor and control the wastewater treatment process. Now let's look more closely at the role oxygen plays in the treatment process.
On my left are the aeration tanks. Over here is the oxygen generation plant. Pure oxygen is piped from the oxygen plant to the aeration tanks. You can see the green pipe that carries oxygen between the two plants. Now let's look at how oxygen is used in the aeration tanks.
I'm currently standing on top of the aeration tanks. Below me are separate tanks containing thousands of gallons of wastewater. The wastewater is being infused with oxygen from our oxygen generation plant, which allows the microbes in the tanks to digest wastewater more efficiently. Let's think for a minute about the air microbes used at the wastewater plant.
In the background is our oxygen generation plant. As you may know, there are many gases that compose the air we breathe. Oxygen is only one of them. In normal air, the percentage of oxygen is about 20.9% at sea level. The three other primary components of air are 78.1% nitrogen, 0.93% argon, and 0.04% carbon dioxide. The enriched oxygen we make at the plant is produced by removing nitrogen from the air and produces a concentration of about 95% pure oxygen. So, how do we monitor the oxygen levels? This display, which is called our HMI, or Human Machine Interface, is where we monitor and control the operation of our oxygen generation plant. It is used to trend various measurements by graphing. The operators use this information to make adjustments to the process, such as turning on and off equipment. This instrument is an oxygen purity analyzer. The measurements from this analyzer are used to ensure the purity of the oxygen being produced. It is an instrumentation technician's job to calibrate this analyzer to ensure its accuracy. Algebraic formulas involving ratios and percentages are used for these calibrations. You may recall air is 78% nitrogen. In this area, nitrogen in air is removed in vessels called adsorption beds. These are our adsorption beds. As the nitrogen is removed, the relative concentration of oxygen increases. The higher oxygen concentration makes the aeration process more efficient. It is important to measure and control the oxygen level in the tank. So let's look at how this is done. This particular device is used to measure the rate of flow of oxygen in the system. This is a gas flow meter. It is important to include temperature and pressure measurements when monitoring the behavior of gases. For example, the temperature and pressure affect the volume, density, and resulting flow of a gas. I find my job as an instrumentation and controls technician to be very challenging, but also extremely gratifying. As an instrumentation and controls technician, I use electronics, mathematics, and chemistry on a daily basis to monitor and control our treatment process. Because technology is always evolving, a well-rounded education and technical background, which includes the study of mathematics, electronics, and chemistry, is essential.
Over the years, I have found the field of instrumentation to be very challenging and rewarding. Working in the wastewater industry has given me a great deal of pride because I know the results of my work are helping to improve the environment. Also, having a stable job with a good salary and benefits is a big plus.
For more information about a career in the wastewater industry, please check out the Baywork website at baywork.org, where you can watch and listen to our personal stories as well as review career information about the water and wastewater industry.